So the second topic that we are going to discuss is about surface charge density and the volume charge density. So we are going to represent surface charge density with the sigma, and we are going to represent volume charge density with the rho. So for surface charge density, that is sigma, if the charge is distributed over a surface area, okay, so we can see the diagram right by on the right side. Then the distribution is called surface charge density. So charge has been distributed in a surface, or we can say that in a area covered where we have length and breadth. So the surface charge density is the charge per unit area. Okay, so it is the formula says, which says that it is the charge per unit area where it has been distributed. So its SI unit is coulomb per meter square, as because it relates with area, and we saw the linear one, so it was carrying the only length, so that was it was coulomb per meter. So sigma is equal to charge by per unit area, that we can say Q by S, or sigma is equal to dq upon ds. What is the reason? Because a small element we have taken one from the whole area, where the small element area was a ds, and the charge distributed in the small element is dq. So we could write the small element on the whole area is dq upon ds. So if I integrate the small element over the whole surface, then I could get that q is equal to integrations of sigma ds. So this is the expressions for surface charge density. Now we talk about volume charge density. Then we have, if the charge is distributed over a volume, then the distribution is called volume charge distribution. So volume charge density is the charge per unit volume. Now the charge has been distributed over the whole volume, where it consists of length, breadth and height. So the SI unit is coulomb per meters cube. So we have rho is equal to Q upon R, we have represented with R, and so we can say rho is equal to dq upon dr for the small element. So if I take a small element on the whole Q, so I can get it is a small element volume, elementary volume, that we have dr, and on that dq charge has been distributed. So I can say that rho is equal to dq upon dr. So if I integrate the small element, so I can get integrations of rho dr, and so that's the expressions for volume charge density.